Good morning, students.
Good morning, sir.
All right.
Morning, sir.
But I can, all right, so but I can see the screen clearly. But I can see the screen?
Yes, sir.
Yes, sir.
All right, good. Okay, let's do this. So, all right, so today we are going to be revising using a past paper. And based on where we are on the syllabus in our preparation, basically only 2 questions on this paper we need to skip over. So out of the 10 questions on this paper is 10. Let's see if it's 10. I think this is a 10 questions paper, it's an 11 questions paper. Let's see. As I mean, the syllabus changed recently, so sometimes I don't remember which one is 10, which one is 11. All right, so this one is an 11 questions paper. And imagine that out of 11 questions, we only need to skip over 2 based on what we have covered. So you know that we have gone a far way in the syllabus in the program. All right, so we can do 9 questions on this paper. I was thinking about starting at the back and working my way to the front. I don't know. I think I'm just gonna start at the front and work my way to the back. All right. Sometimes I like to start at the back because persons are far more attentive at the beginning of the class rather than at the end. And you know, sometimes it is the questions at the end that requires the greater level of focus. But then the other advantage of starting at the front is that some persons join late, and we want them to catch the more structured questions at the back. All right? So what I might do is just try to work through the questions at the front a little bit more quickly than normal, since you know we would have gone through these things multiple times, and maybe sort of slow down when we get to the back at the the section 2 questions and so on. But you can guide me. If I'm going too fast, you can let me know. All right, that's the bottom line. All right, so this is the January 2018 paper. More maths equal better maths. More than likely I would have done questions on this paper already as we did the topics, but not a problem. We can always repeat during the question because it is revision after all. And as I always say, more maths equals better maths every time. All right, so let's look at number 1. Let's get the blue. So let's go straight into it. So number 1 is a using your calculator question. Use a calculator otherwise to calculate this thing, and we must give our answers a fraction in lowest terms. So it's a matter of typing this expression in the calculator exactly as it is. I have my calculator up on the screen over here, and I'm going to just type this thing in the calculator and make sure that it appears exactly as it is. So this first thing is a mixed number. So you need to get one of those textbook display calculators that you can put in the mixed number so that it appears exactly as these are. In fact, we have 3 mixed numbers in this. The first mixed number is 5.5. 5 and 1 over 2. And then we are dividing another mixed number, which is 3 and 2/3. See? 2/3. And then we're adding another mixed number, which is 1 and 4/5. And you sort of make sure that what you type. Somebody said something? Okay, they want to make sure that what you type there is exactly what we have. But the question wants to answer as a fraction. So if those calculators given as a decimal, your calculator can also give as a fraction. So if I just look at it as a fraction, this is it. You can put back a mixed number, this one, or you can put this one as a fraction in lowest terms. So I'm going to write equals 33/10, which is the same as 3 and 3/10. And basically that is it. Done. Now, if you're doing this step by step, the key thing is that you have to do the division part first before you go and do the addition part. You have to do the division first, all right? But since I say use a calculator, you can use the full capacity of a calculator and type the whole thing in there. And this one now wants us to do this thing and it wants us to give our answer as an exact value. So again, we're going to type that in the calculator. That's 165 times, that is 0.38 squared, and it is 23.826. That's the answer, 23.826. Nice and easy. Then they want us to give the answer for part 2. That is the 23.826. That's the answer in A2. They want to give it correct to 1 decimal place. So this is the first decimal. So let me write it back. 23.826. And I want to correct it to 1 decimal place. This, no, 2 decimal places, sorry, 2 decimal places. So this is the second decimal place. So this is the position that we're correcting. And we're using this number to correct this. So because that is 6, a number greater than 5, it will increase this 2 to 3. And so this becomes 23.83. They wanted to 3 significant figures. So let's write it out again. 28.826. They want to correct the 3 significant figures. The first significant figure is the first non-zero value from left to right. So if you're counting significant figures in this will be 1, 2, 3. So this is the third significant figure. So your answer must have 3 digits in it. And you're using this number that comes after the third significant figure to correct this one. So because this is a 2, a value less than 5, it's not going to change this 8. And so to 3 significant figures, I wrote 28, it should be 23. Not 28, 23. 23. Right, so it's not going to change the 8. And so it comes back as 23.8. And then I want it to the nearest whole number. So if I write it again as 23.826, the whole number is a number before the decimal point. All right? So it's a number before the decimal point. You don't want any fraction part of it. So this is your whole number. So using this 8 to correct this whole number of 23. Because the 8 is a number greater than 5, or 5 or more, then it's got to increase that 23 to 24. So this becomes 24 to the nearest whole number. Everybody got that? But okay?
Yes, sir.
Yes,
All right.
sir.
Yes, sir.
Let's continue. All right. Next part now says, Mr. Adams invested $5,000 in a credit union and received $5,810. So right away, the $810 is the interest. All right? That is inclusive of the interest that's after 3 years. It says calculate the simple interest earned. That's the difference. So he invested 5,000, he got back 5,810, so the interest is 810. But let's show the calculation. The interest, let's call it interest I. Let's call it interest I so we can reference it going forward. So I becomes 5,810 minus $5,000. Put a dollar sign in front of it. And so the interest is $810. That's the interest. Nice and easy. It says the annual interest rate paid by the union, the interest rate. So this is a simple interest question. I say simple interest. And so you're going to apply the simple interest formula, which everybody should know. Is I equals PRT divided by 100. This is one of the formula, long-standing formula that everybody must know. Once you operate in real life, that's one of the real life formula that everybody must know and use. And what are the terms in this formula? The interest is equal to the principal amount, that's the amount invested, multiplied by the rate of interest as a percentage, and that's why they put the 100 under here, because the rate is as a percentage, and it's usually per annum, right, per year. And the time, the T is time in years. The T is time in years because the rate is a rate per annum, the rate per year, see, the annual rate. So they're aligning the question with how real life usually goes. Interest rates are usually expressed as a per year rate, per annum rate. All right? And so the time in the formula is time in years. So if, for example, instead of 3 years, they had given us, for example, 24 months, then that 24 months would be 2 years. And so the T would be 2. The T would be 2. So bear in mind that the time has to be in years in this formula. All right? So what is that mean here now is that we are trying to find the R, we're trying to find the rate. So it's a matter of transposing to make the R the subject. So I'm going to multiply the 100 across here, and then I'm going to divide by the principal and the time. Because we know those, you know. We know those, you know. We know that the principal in the formula is 5,000. That's the amount invested. We know that it's a dollar. I don't have to put a dollar sign. We know that the interest is 810. We know that the time is 3. I want to get the R out of this. So from this formula, if we want to make R the subject, then we multiply the 100 first. We're going to get 100I divided by the P, and also divided by the T. And that leaves R as a subject. So when you drop your values in this, you're going to get the value for R. I'm going to shift this up a bit so we can have a little bit more space. All right, so from this formula, we get this. Let me change the color. Let me look at a little bit more presentable. Change the color of this as a formula. So this is the formula that we're using. All right, and so we're doing the work here now. And this also, these are the values that we have. Changes to red as well, as values that we have. And so we're working now our calculation here. And so the R that we want is going to be 100 times the interest. 100 times the interest. Our interest is 5, is 810. The value of the interest is 810. Divided by the principal of our 5,000. And also the time of 3 years. And if I were you, I would type this in the calculator exactly as it is. All right? Because some people, even though they have this, they'll do the wrong thing on the calculator. Right? So you have to make sure you have a calculator that can type that in as exactly as it is. So it will be 100 times, let's put the fraction first. Fraction 100 times 810 divided by 5,000 times 3. And that's 5.4. So the interest rate is 5.4% per annum. It's a percentage value. That is it. But go to that. But okay with that?
Yes, sir.
All right. The length of time it will take for Mark Adams' investment to double, to be doubled. Now, when the investment is doubled, remember, I know it started at 5,000, you know. When it is doubled, it becomes 10,000. And when it becomes 10,000, it means that the interest, let's put the dollar sign on it. It means that the interest is now equal to 5,000. Or you can say the interest is now equal to the principal. When it is doubled, the interest is 5,000. Okay, we go from 5,000 to 10,000. You've doubled the investment. It means that the interest is 5,000. It is now matching the principal. So we can basically use this relationship when it is doubled. So we're going to start back with the formula. The question is asking us for time. It's asking us for time. This part is asking us for time. So we'll go back to the formula that is I equals PRT divided by 100. You know, trying to make time the subject. We're going to multiply by 100 again and divide on the PT, the PR, sorry. So the T would become equal to 100I divided by the P and the R. But we just said in this case, the I and the R, the I and the P equal. Right? The I and the P equal. So if you extend this calculation, let's change to the purple. Then the T that we want would then be equal to. Remember these two equal enough. So the I and the P equal. So they cancel each other. And so it just reduces to, let me mark them out. They cancel each other. Because they're equal. The I and the P equal. So they cancel each other. So you're left with 100 over R. So you're left with 100 over the R. And the R is 5.4. So it's 100 over 5.4. And you calculate that. 100 over 5.4. And that's 18.5%. 18.5. 18.5 years. It's time. Time in years. 18.5 years. The length of time. Call it 18 and a half. So I'm going to say 18.5 years. Let's see what they get. So this is 18.5. 18 and a half years almost. 18.5 years. You have to say years. You cannot just say 18.5. You have to give the time in years. And that is it. What about that? 18 and a half years. All right, just about 18 and a half years. In a sense, you might want to say take 19 years, right? You might want to say take 19 years, assuming that the interest is calculated at the end of the year. So usually institutions don't necessarily go and tell you what the interest is after 1 month, and then after 2 months, and then after 3 months. They'll just wait until the year is over and give you the interest at the end of the year. But in exact terms, it is this. But I would say 19 years. Right? So I would say after 19 years. So I would say i.e. 19 years. It's after 19 years, investment is doubled, 18 and a half. I would say 19 years. Because it passes after 19 years, it's gonna be more. It's gonna be more than double, you know. Right? But it's past 19 years after 19. But let's leave 18.5. That's what we'll get by calculation. But if the question was worded another way, I might have said 19 years. Just simply because they don't normally calculate interest on these things in the middle of the years. In the middle of the year. Some places do, but not. The normal way to do it is at the end of a year. They apply your interest. All right? But let's continue to number 2. Number 2 now, this is what we call a binary operations question. All right? See, this is an operation, and it's operating on 2 things. That's what we call it binary. It's an operation on 2 things. And what it is that this operation, instead of it uses a combination of the normal operations that we know: the plus, the minus, the division, the multiplication, square root, and so on. Those basic operations that we know, these are the basic operations. And what the binary operation is like they're creating a new operation that is combining those basic operations, and they're defining it for us. They're telling us that what it is here. So this comprises of an addition inside here. This will be a multiplication. The 4b is a multiplication. And then no, this is a square root, which is like a power, right? This is a square root, which is like a power. But in any case, what it is that the first value goes here, and the second value goes there. So in this case, if we want the value of 1 plus 2, it is like the A is 1 and the B is 2. So then this will be equal to the square root. The first value goes here, which is a 1, plus 4 times the second value goes there where the B is, which is that 2. This one here becomes 9, because 4 times 2 is 8, 8 and 1 is 9. So it becomes the square root of 9, and square root of 9 is 3. So the answer there is 3. The next part says we are to determine whether the operation is commutative or not. If it is commutative. What does commutative mean? It means that the operation is commutative if, for example, A star B gives the same result as B star A. Means that when you reverse the order of the operation, the answer is the same, then it is commutative. It will be commutative if this happens. So because we already know the result for 1 star 2, we know so 1 star 2 is 3. We can test to see what 2 star 1 will give. So let's write it down. 1 star 2, we know is equal to 3. And we can say, and we're going to work out now 2 star 1. So we are reversing this operation to see what the result is. So we're going to calculate 2 star 1. Now in the case of 2 star 1, the A becomes 2. So you're going to put the 2 where the A is. You put 2 first. Plus 4 times, and then the 1 becomes the B. Comes in the place of the B. So you're going to put 4 times 1. So this works out now. This works out now to be the square root of this is 4 and 2 is 6. And the square root of 6 is not 3. It is not 3, you know. Remember when we break this way, we get 3, you know. So we can draw the conclusion and say, since 1 star 2 is not equal to, this is symbol for not equal to, 2 star 1, it means that this operation star is not commutative. Since that is, they're not equal, it therefore means that star is, we can say operation star, therefore means that the operation is an operation on 2 numbers. Star is not commutative. Shift this over so I get a little bit more space to write this out. Is not commutative. But okay with that?
Yes, sir.
Good. All right. Beautiful. I'm assuming that if somebody is not okay with it, they will say something. You know? All right. So let me continue.
Yes, sir.
Down here now says we have to solve this. Remember, solving this is the same steps as you will be solving 3 minus 2x equal 5. The only difference with the inequality, remember, is that if you have to multiply or divide this one with a negative number, you have to reverse that inequality sign. That's the only thing that's different between these two. But in essence, you're trying to make x the subject of both of them. All right? So let's take this off and do it with this one. Remember now, for the inequality, if you have to multiply or divide by a negative number anytime in making x the subject, you have to reverse this inequality sign. That's the only way for the inequality to remain true. That's a key thing to remember about these simple linear inequalities. All right. Now the first thing we want to do is subtract this 3 over here. Let's write the step. We're going to subtract the 3 first. Let's write the step. Minus 3 as a first step from both sides. So you take the 3 and bring it over here. Same as say subtract 3 from both sides. You're going to end up with minus 2x. You see, I did not throw away the minus because all I moved was the 3. So the minus 2x remains. So minus 2x is now greater than, we subtract 3 from this side, I get 2. But good so far?
Yes, sir.
Then I need to get rid of this 2. To get rid of it, I need to multiply both sides by this negative 2, not 2, negative 2. So my next step to get rid of this negative 2 is divide by negative 2. So I'm going to write it. The next step is to divide by a negative 2. But because I'm dividing with a negative number, I have to reverse the sign. So I have to write it. Reverse the greater than sign. I have to reverse it simply because I'm dividing with a negative number. When I divide, I multiply an inequality with a negative number. You have to remember to reverse the sign. So when I divide by the negative 2, this is going to become a less than. So my next step is going to be when I divide this side by negative 2, it just comes x. This sign is reversed to less than. And when I divide this by negative 2, it becomes a negative 1. See there, 2 over negative 2 gives me negative 1. That's what I have here. Okay? And then no, this is my solution. That is it. That's my answer for this inequality. X is less than negative 1. The next part now wants us to represent this on a number line. Represent this inequality on a number line. But the first thing to know is that the critical value is -1. In other words, your inequality, your statement starts at -1. So I'm going to put a circle on the -1 here, put it on the number line. But I'm going to leave the circle unshaded. Why am I leaving it unshaded? Because there's no equal in the inequality. If this inequality instead was a equal, I would have shaded the circle to show that the -1 is included. But since there's no equal there, I'm going to leave the circle there unshaded to show that the -1 is not included. I only want values less than -1. And then the values that are less than -1 are on this side. So I put the arrow on this side of the -1. And I can write it x less than -1. And that's my number line. But I go to that.
Yes, sir.
Beautiful. Let's continue. Next part says, statement 1. 2 tickets, that's the number of tickets, two adult tickets, 2 adult tickets, and 3 children tickets cost $43. 1 adult ticket and 1 child ticket, ticket for a child is $18.50. Let X represent the cost of an adult ticket. And you're buying 2 of them, so that is 2X. And Y represent the cost of a child ticket. And you're buying 3 of them. So basically then, this statement appears 2X. The and means plus 3 times the child ticket, that's 2Y. All of that equal this. Down here now is 1 adult ticket, which is a X. The and means plus 1 child ticket, which is a Y. Y is the cost of a child ticket. So it's Y dollars, Y. All of that now is equal to that. And this one is equal to that. They want us to write 2 equations. Easy. Have them there. 2X plus 2Y. It should be 3Y up here, so not 2Y. 3Y. 3. 3 children tickets. So 2X plus 3Y is equal to 43. I don't have to put dollar sign on it. And the other one is that X plus Y is equal to 18.5. I don't have to put the dollar sign on it. That is it. Then it says, solve the equations to determine the cost of an adult ticket. So this question is asking for X. So if I'm going to solve these 2 equations for X, I need to eliminate the Y. I need to eliminate the Y. So let me just put them over here. I'm going to write them back. Let me write them back down here and show you how we solve them quickly. So I have 2X plus 3Y equals 43. And I have X plus Y equals 18.5. Now, if I want to eliminate the Y, because I want X to be the subject, so I need to eliminate the Y. I need to make this into a 3Y, so I can subtract this equation, all right, from it. So I'm going to leave this equation as it is. I'm not going to change it. I'm going to write it as 2X plus 3Y equals 43. I'm using an elimination method. But I'm going to multiply this one by 3. I'm going to multiply this one times 3. So when I multiply it by 3, this becomes 3X and this becomes 3Y. So I get 3X plus 3Y equal, I also need to multiply this by 3. Let's do it over here. 18.5 times 3. 18.5 times 3. And I get 55.5. So I'm getting 55.5. And then to eliminate this now, because this is a 3 and this is a 3, I need to just subtract the 2 equations. Subtract. I want to subtract them. I'm doing the bottom one minus the top one this way. That's why I'm subtracting them. Subtract them this way. Subtract them this way. The bottom one minus the top one. So you do the bottom one minus the top one. You're going to have 3X minus 2X is X. 3Y minus 3Y, that gone. equals on the right side, you're gonna have 55.5 minus 43. So let's just minus the 43 now. Minus 43. I'm getting 12.5. So x is 12.5. But I'm asking for the cost. I will put it as money. So I'm gonna say that is $12.50. That's my answer. Because I asked for money, cost, $12.50 is a cost. But I go to that?
Yes, sir.
Yes, sir.
All right, beautiful. Let's move on. I said skip number 3, right? That is sets. We're gonna skip that. We're gonna do sets later on. Because even though sets don't come on paper 2 anymore, it comes on the multiple choice. There are about 5 sets questions on the multiple choice. So we have to still do the topic of sets. But not yet. And I said that you're also, well, let's do number 4. I don't think I need a calculator right now, so let me take that off. All right, so now, question says, they give us the equation of this line, and I want us to write it in the form y equals mx plus c. In other words, make this y the subject. All right, write the form y equals mx plus c. So, multiple ways this can be done. I can take this 4y, bring it over here, make it positive. Take this 5 and subtract it over here. Let's do it that way. All right, so I'm going to do it that way. I'm transposing this to make y alone the subject, but I want the y to be a positive y. Or I can leave the y here still and transpose everything else. Let's do it 2 ways for you. I'm going to transpose the 4y over here and make it positive, and take the 5 over here and subtract it. So I'm going to get, when I do that, I'm going to get 3x minus 5 equals a positive 4y. Then now, to get the y by itself, I need to divide through by the 4. Divide everything by 4. All right? So when I divide 2 by 4, let's write it, divide by 4, I'm going to get, this becomes 3 over 4x. This becomes 5 over 4 equals just a y. So I can just turn this around now, just flip it around and write that, i.e. that is, the y is equal to 3 over 4x minus 5 over 4. If I do it the other way, where I leave this on this side, when I move this 3x over here, I would get minus 4y equals minus 3x plus 5. Why did I write it like that? Because I want the x term to be first, as it is on this side. Then I would need to divide by this negative 4. So I would have to divide this by negative 4, divide this by negative 4, and divide this by negative 4. All right, that's what I would have to do next. Now, if I divide 2 by negative 4, this side is going to become y. When I divide this by negative 4, the negatives cancel, and I get 3 over 4. X is like me have the negative and the negative, but they cancel. And then when I divide this positive 5 by negative 4, it becomes, like I get plus 5 over negative 4. But plus 5 over negative 4 is the same as minus 5 over 4. And so it's the same answer that we have here. All right, so maybe this way is a quicker way because just 1 line less. That is it. It says, hence, determine the gradient of the line. In this case is this 3 over 4. Simple as that. When y alone is a subject, when y alone is subject, this value is your gradient. It's 3 over 4. So you're just going to write the gradient of the line M is 3 over 4. Nice and easy. All right, next part says, the point P, which is this, lies on the line L. Determine the value of R. Now, what this means is that if this point is on the line, then it satisfies the equation of the line. You can fit those coordinates in it. You can fit those coordinates in it. That's what it means. If the point is on the line, then it satisfies the equation of the line. You can also fit it in this one too, you know. Why am I using the top one? Because I recognize that the R value that I need down here is actually an X value. So it's more convenient to fit it in that one. All right, so we're going to substitute it in that equation. If it is on the line, it satisfies the equation of the line. Let me write it. It is 3x minus 4y. So I'm going to write 3x minus 4y equals 5. Right? That's the line. That's the line. So this point, we can fit it in that equation. We fit it in there. Let's write what we're gonna get in a different color. We're gonna get 3 times r, because the x value is r. And then the y value is a 2. So I'm gonna put 2 right there for the y value. So we're gonna get minus 4 times 2. All that is equal to 5. And we're solving for the r. Solving for the r. So this right here, so now is a negative 8. Negative 8 goes over there, becomes a positive 8. So if we continue up here, we're gonna have 3r equals 5 plus 8. 5 plus 8 is actually 13. And you have to divide by this 3 now. And so the r becomes 13 over 3. That is the r. But okay with that?
Yes, sir.
If the point is on the line, then you can fit it into the equation of the line. It satisfies the equation of the line. Simple as that. This one now says, find the equation of a straight line passing through this point, which is perpendicular to L. So since you want a perpendicular line, the line that you want has a gradient. Let's call it line 2. The line that you want, let's call it line 2. The gradient of line 2 will be minus 1 over the gradient of line 1. This is line 1, you know, this first line that they gave us. We're calling it line 1. And it has a gradient of this. Right? So the perpendicular gradient is obtained by taking this and putting it under here to get what the perpendicular gradient is. The line with a perpendicular, line that is perpendicular. But a quick way to do that calculation, as we said, is to flip this one that we have and change the sign. That's what this calculation will result in. So if we flip the 3 over 4 and change the sign, it's simply going to become negative 4 over 3. So this is the gradient of the line that you want. And you're working that gradient with this point. Let's call a point something. Let's call it P so we can reference it. You know, we'll call this one P already. So let's call this one Q. So we'll call this point Q. So we want the line passing through this point Q with this gradient, because this is the perpendicular gradient to the first line. So the equation of that line would be the BFF formula for the equation of a line. We call it the point gradient formula. It will be y minus the y value at Q equals the gradient of the line that we want. Let's call that M2 right here. Into x minus the x value at the point Q. So how it works is that this gradient comes here. Then the y value on the point, it goes here for the yq. And the x value on the point, which is the 6, goes here for the xq. So basically, let's substitute in those values now. So we're going to get y minus 0, because the y value at the point is 0, as I said. Equals the gradient of the line is this, right here, which is negative 4 over 3. Into x minus the x value on the point is 6. So the line passes through is 6. And this side we're going to just be y. So we can write it under here. Y becomes equal to, multiply this by the x, we're going to get negative 4 over x. 4 over 3x, sorry. And then this minus make this firstly a plus. And then when you write the numbers, you're going to get 3 into 6 goes 2 times. And then the 2 times 4 is 8. So in terms of the numbers, I'm going to get 8. Or you could say 4 times 6 is 24. 24 divided by 3 is 8. Anyway, take it. This is our answer right here. That's the answer, this thing. But okay with that? Perpendicular line.
Yes, sir.
All right. Beautiful. Next one. It says draw the line x plus y equals 10 and the line y equals x. Well, these are 2 easy lines to draw. This is what I call the x plus y line. If x plus y equals 10, it crosses the y-axis at 10 up here and also crosses the x-axis at 10. Remember, we got a lot of those lines where we did inequality, linear inequality. All right? It will also pass through the point 5, 5. Why? Because 5 plus 5 is 10. That's x plus y is 10. So it passes to the point 55 as well, right? So that will be here. So basically, I want the line passing through these points. Let's just extend it down and label it down here. So x plus y equals 10. Then I want the line y equals x, another easy line. It passes through points where the x and the y value is the same. X equals y, so the x value and the y value is the same at points on that line. So it passes through 0, 0, and it also passes through this 5, 5 point right here. So it goes like this, right down the middle of the graph when the scales are equal. When the x-axis and the y-axis have the same scale, the line y equals x passes right down the middle. Okay, let's extend it right through. Extend it right through. You have to draw with a straight line now. Don't draw a zigzag like me. I'm not using a ruler. Label the line with the equal sign. That is y equals x. Y equals x. I can also extend this one backwards as well. We'll pass through that point. You just have to draw those lines with a ruler, guys. Then the question says, on the grid, which is down on this grid, shade the region which satisfies these 4 inequalities. All right, let's talk about them now. What each one means. This first one, I'm going to shade it in red and mark it. Right? It is x greater than 0. Now, this means, hold on a second, guys. Hello? I'm in class. Sorry about that. So this means above an unbroken line. All the lines are unbroken because the equal is in all of them. The lines are all solid. Above the solid, and the solid line is x equals 0. Now, x equals 0 is the y-axis. This is the line x equals 0. This line. So this inequality, the first one, is referring to the region to the right of this line. The region that we want is to the right of this line x equals 0. This is the line x equals 0, the y-axis. Then this one now, again, because of a greater than, it means above. The line is again solid because the equal is a part of the equals. You're going to draw a solid line, which is there. And the line we're talking about associated with this inequality is y equals 0. But y equals 0 is actually the x-axis. This x-axis is the line y equals 0. That's the line y equals 0. I'm going above that line, so I'm going to put the arrow pointing up. So the region I want, we know says over here. It's over here. We're in the first quadrant. To the right of the x-axis and above, to the right of the y-axis and above the x-axis. That's the region that we want so far. We're narrowing down the region that we want. Then this one now. Since the y over on this side of the inequality is positive, this less than means below. When the y on the left side of the inequality is positive, this, as it is here, less than means below. So for this one, we want below. We want below the line. We want a solid line again because the equal is there on the part of the inequality. So we want to draw a solid, we want a solid line, which is already there, a solid line. And the line associated with this inequality is the line x plus y equals 10. Because this is a, if you replace that with an equal, you get the line associated with it, which is x plus y equals 10. X plus y equals 10. And this is the line we're talking about. We want below it. So I'm going to put the arrow pointing down on that line. So we want region below this line. Right? So the region I want is below that line. So I'm going to put the arrow pointing down up here to remind me that I want region below that line. Now this inequality now is kind of tricky. Why is it kind of tricky? Simply because the y is on the right side of it. Right? So a lot of persons are going to see the greater than sign and think it means above. But no. It doesn't mean above because the y is on the right side. If I have to take this inequality and write it another way, I make the y go up on the left side, then it will be y less than or equal to x. If I reverse it, because to say x is greater than or equal to y is the same as reading it the other way and say y is less than or equal to x, which is what I've written here. Now that the y is on the left side of inequality, this less than sign means below. So this inequality now means below a solid line again because of the equal. And the line we're talking about is y equals x, which is this line up here, y equals x line. We want to go below that line. So the region I want is below this line and below this line. And I will say it has to be in this quadrant as well. So which region is that? Look, below this one and below this one and above this one. So the region I want is inside here. Let me shade it in a different color. Let me shade it in purple. It's this region that we want. You have to be careful. That third inequality, or the fourth one that I've circled up here, this one, messed up a lot of persons. Because a lot of persons ended up shading here because they read this one inequality as above because of the greater than. But the greater than means above only when the y is on the left side of the inequality and is positive. All right, so this is the region that I want. But okay with that? This is the required region for the four inequalities. But okay with that?
Yes, sir.
All right. All right, so question like this you do again. All right, that finishes that question. Moving right along. So I say you to skip over number 5, right? Because this is a topic we're going to be doing next. Plane and solid geometry. This is a plane geometry question. We're going to be doing polygons and so on as our next topic. This is a polygons question. And that's why I said skip over this one, right? I don't like to do questions on papers that we have not yet covered in class. So we'll do this one, this topic we're gonna do next. And even this part of this question is a solid geometry question down here, which is something that we're gonna do as well. All right. So that's why I said skip over this one for now. So we get back to this question again because more than likely you're gonna have to do this paper again, you know, when we do mock exams. So we start the mock exams, you're gonna have to do this paper again under exam conditions, right? Where, you know, as I said, under exam conditions. All you'll have is a calculator to do this paper. Do it out of your head. All right, we're getting to that stage, starting on March 16. That's when we're going to start our mock exams, March 16. All right, the first mock exam will be on March 16. All right, let's continue. So that question, we'll do it some other time. Then we'll come to this one now, number 6, which is a transformation question. Once you see that diagram, you know the structure of the exam papers, you know what question you have in front of you. This is a transformation. And I see this triangle, I know it's a transformation. It's a diagram shows triangle PQR. All right? And then it says state the coordinates of R, which is right here. That is the point 0, 3. Look at it carefully. At this point, you don't go left or right, so the x value is 0, and the y value is clearly 3. Because if you look at the scale, this would be 1, this is 2, so this would be 3, a y value of 3. So that point is clearly 0, 3. So let's write it, 0, 3. So R is a point 0, 3. All right, done. Next one says, draw these triangles. They want us to draw P prime, Q prime, R prime, a reflection of PQR in the line y equals 1. So if we're going to reflect it, we need to draw the line y equals 1. Remember, y equals 1 has to be a horizontal line passing through 1. How we can know? By remembering that the x-axis is y equals 0. So y equals 1 has to be horizontal like the y-axis, like the x-axis. Right? The x-axis is y equals 0. So y equals 1 has to be horizontal just as it passes through 1. So line y equals 1 is going to be, let me draw it in red. I'll draw it in blue. Yeah, draw it in red. It's going to be this line, horizontal line here. Is y equals 1. That's the line we're reflecting in. Y equals 1 is that line. X-axis is y equals 0, so this is y equals 1. I want to reflect this triangle in it. So remember, you do your reflection 1 point at a time. Let's zoom it up and do it now. Let's draw it in blue. Do your reflection 1 point at a time. So P is 1 unit. It's going to go 1 unit on the other side to there. So P is coming here. So that's where P prime would be. Then this point, how many units to the line? 1, 2, 3, 4. It's going to go 4 units on the other side. 1, 2, 3, 4. So it is coming to here. That's where it is coming. All right. 4 units down to here. So 4 units on the other side to there. All right. So pay attention to the details. Everything important. All right. So that's where it's going to be. That is Q prime. And then R now is 2 units to the mirror line. 1, 2. It's going to go 2 units on the other side of the mirror line. 1, 2. Notice I did not try to reflect the entire triangle all at once. So this is where R prime would be. R prime is right there. All right, so let's erase these other lines. That is where R prime would be. And then now that you have the points in place, you can draw the triangle. This is the image. So I did my reflection 1 point at a time. Don't try to reflect the entire triangle all at once. That is how you run into problems when you try to reflect the entire triangle all at once. Do it 1 point at a time to be safe. Image distance equals object distance from the mirror line. That's the first triangle. But good at that?
Yes, sir.
All right. Next part says we have to now reflect. We have to now draw a double prime triangle, P double prime, F double prime, R double prime, the reflection of the prime one. So this one that we just got, we're now going to reflect that one in the line x equals 0. So the important thing now is which line is x equals 0? X equals 0 is actually the y-axis. You have to know that. So them stated, they could have easily said the y-axis. You know. But this question is testing your knowledge. Do you know which line is x equals 0? X equals 0 is the y-axis. So we're now reflecting this triangle in the y-axis. So reflecting in this line, the y-axis. This y-axis now is the line I'm drawing here. That is the line x equals 0. The y-axis is the line x equals 0. You have to get comfortable with these things, guys. Lines like x equals 0 and y equals 0 and x equals 1 and y equals 1. You get comfortable. This is the line x equals 0. So we're now reflecting this blue triangle in that line. We'll do the same thing again. Right? We'll do the same thing again. 1 point at a time. So firstly, R is on the point on the mirror line. It's that's called now an invariant point. The point on a mirror line, we reflect a point on a mirror line because the object distance is 0, the image distance is going to be 0. It's called an invariant point. So this is an invariant point under the reflection because it remains there. So I'm going to put this as R double prime. So this becomes R double prime as well. So this point is also R double prime. R prime and R double prime is the same. Then use this point now, this point. And reflecting it is 2 units to the mirror line. It's going to go 2 units on the other side to here. That's where it's coming. All right? Reflecting it in that vertical line. So this is going to be P double prime. All right? And then this point is also 2 units to this vertical mirror line. It's going to go 2 units on the other side to here. So this is where Q double prime will be. And now that I have the 3 points, I can draw the triangle. Let me move these R and R double prime out the way. The same point. I move them out the way. I can write them back. So draw the triangle now. This is the image triangle. So this is a compound transformation that we have now. You have to be careful, you know. Start thinking now, compound transformation. Let me write back these 2 points. So this point is both R prime and this is also R double prime. Put R double prime here. So R double prime. All right, that is that point, this point on the y-axis right there. What did we do? We did a reflection in this line, draw it in purple. We did two consecutive reflections. You know? We did a reflection in this horizontal line. Then we did another reflection in this vertical line. So we're supposed to start think of compound transformation. You know? We did two reflections over two lines that intersect. This horizontal one first, and then this vertical one. The two of them intersect right here. So I can tell you right off the bat that those two reflections over those two intersecting lines is equivalent to a rotation. So to go from this to this would be a rotation, and it's going to be a 180 degrees rotation about this point where the two lines intersect. Now, why is it 180 degrees rotation? Simply because the angle between these two mirror lines is 90 degrees. Angle between these two reflection mirror lines is 90 degrees. So the rotation is going to be twice that, 180 degrees. And then the center of the rotation, the center of that rotation, oh, I've erased something. The center of the rotation is at this point where the two mirror lines intersect. That is the center of the rotation. So I know to go from this to this is a 180 degrees clockwise rotation about this point. We study that, we learn that. We know that two reflections over intersecting lines is equivalent to one rotation. The rotation angle is twice the angle between the two mirror lines. And the center of the rotation is at the point of intersection of the two lines. All right, so we know that already before we even answer the next question. And I must ask you something relating to that. But let's see. So we have those two things, right? And we'll draw them. Down here now. See it here now? See it here now? It says describe fully the single transformation that maps the double prime one onto the original one. This means that they are reversing, you know. Remember, you know, what is now, you know? To go from this to this. We just said a while ago now, it will be a clockwise 180 degree rotation about this point. That point is that. That point is the point 0, 1. This intersection point is the point 0, 1. 0, 1 is that point. Right? So we know to go from the original triangle, this one, over to this one is a 180 degrees clockwise rotation about 0, 1. But the question is asking us for the reverse. It's asking us from this one to this one. So it's asking us for the reverse or the inverse transformation to go the opposite way. So the opposite or the inverse of this reflection, this transformation, this rotation, is the same angle, the same center, the same rotation, but the opposite direction. So basically, to go from this prime, double prime triangle, to go from this one back up to this one, we're just going to do the opposite. We're going to rotate this way instead. We're going to reverse the transformation that way. So it's going to be an anti-clockwise 180 degrees rotation about this point. Now, when you describe a rotation, you have to give the three components: angle, direction, and center. So once it's a rotation, you have to give the three components. This question is testing your knowledge about compound transformation, which is on the must-know sheet that I gave you. That two reflections over intersecting lines, which is what we have here, two mirror lines that intersect, is equivalent to a rotation. The rotation angle is twice the angle between the lines. Since the angle between these two lines is 90 degrees, then the rotation angle is 180 degrees. And then The center of rotation is at the point where the two mirror lines meet, which is 0, 1. So I'm going to describe it now, the answer. So the answer for this question is a 180 degree, write it in blue to match that thing that I drew in blue. Is a 180 degrees anti-clockwise. Okay, going the opposite way now, reversing what we did. Anti-clockwise rotation, 180 degrees anti-clockwise rotation about the point 0, 1, because the two lines intersected at the point 0, 1, 0, 1. Let's check that we give all the components. So it's a rotation, we give the name of it. And rotation has 3 components. There's an angle, which you state is 180. It has a direction, which is anti-clockwise, and it has a center rotation. Remember also, guys, that in mathematics, everywhere at every level, anti-clockwise rotation is positive rotation. So instead of saying anti-clockwise 90 degrees, you could have said positive 180 degrees. Instead, you could have said positive 180 degrees rotation. Clockwise rotation, remember, is negative rotation. Anti-clockwise rotation is positive rotation in maths. You have to remember that. When you do trigonometry and so on, at a higher level, these things become important. So I'm introducing these things to you from now. All right? Just in case. All right. So that is that. That is the answer right there. But okay with that?
Yes, sir.
All right. Next part now says that the original triangle undergoes an enlargement of scale factor 2. So the k is equal to 2. All right. It says calculate the area of the image. So this question now is a question testing your knowledge of the relationship of area under enlargement. And you have to remember these things, guys. The more things you know, the better. The mathematics is easy when you just know the basics. You know. That area of the image of an enlargement is the scale factor squared times the area of the object. This means image, this means object. And this is a scale factor. This is what you need to remember for the relationship between area of the image and the object of an enlargement. Area of image is the scale factor squared times the area of the object. If you know that, you don't have a problem doing this question. The question is asking us for the area of the image. It's asking us for this. So to do that, we need the area of the object, because we know that the k is 2, you know. We need to know the area of the object. The object is triangle PQR. So let's look at the object triangle PQR, this one. We can get the area. It's easy to get the area because we can clearly see a base. That is 3 units, and we can clearly see a perpendicular height, which is 2 units. So the base is 3, and the perpendicular height is 2. So the area of the object is half the base of 3 times the perpendicular height of 2. That just becomes 3 units squared, because half of the 2 is 1. So the area of the object is 3. I'm in the exam room, I'm going to leave this on my paper too, you know. I don't have to take it off, I can leave it there. Just that you don't want to be writing outside of these marks. See where this mark is on the paper up here, so? When you're doing the exam, this is a guideline. These are guidelines where you don't write out of. You don't write outside of those markings. Try to stay within those marks, because that's where they might cut the paper. Right? If it notices that do not write in this area, that shaded area, I don't want to write in there. All right, but rule of thumb, try not to write anything outside of those markings. All right, try not to write outside of those markings. Try to keep within those markings. But anyway, this is just us doing this work now. So the area of the image of the object is 3. So I'm going to use that down here then. So it means that the area of the image triangle is k squared, which is 2 squared. 2 squared times the area of the object, which we worked out as 3. That becomes 4 times 3, that becomes 12 units squared. Since we don't know, since we're doing the calculation on coordinate geometry, on a coordinate geometry graph, the unit of measurement is units. Units. So it's like a unit. Right? And so the area is given as units squared. That is why we say units. Our area must have a unit of measure. But go to that. But okay?
Yes,
All
sir.
right. When I post the video, when you watch over the video, if anything, and we do this question, it's a good question. This one, it's a good question. This particular one, I like all the question is set up because it tests your knowledge of some background information. Some background information that you should know. When you know those things, these questions become easy. They are easy, but the ease of doing these questions depends on what you know, and that's why in class I give you a must-know sheet, a sheet of things that you must know, because when you know those things, the questions are like super easy. All right, so this is a knowledge-based questions. You know, when they give questions, they give you when they give questions and they give you your profile, and you have one of them for knowledge. This question now is centered on knowledge, what you know. All right, so that is it. For example, you know this formula, and you know that two reflections over intersecting lines is a rotation. This question is centered on knowledge. The more things you know, the better. That's why you have to study the must-know sheet and practice. All right. Number 7 now, statistics. Let's go. Raw data. See? Raw data statistics. As I see them give you this list of values, no table or anything like that, you know you're doing statistics of raw data. So you're calculating exact values. Remember, only when you do statistics of group data, everything is an estimate. And the method that you use for raw data is different from the methods that you use for ungroup data. It's different from the method that we use for group data. We just finished the topic of statistics the other day. All right, well, let's go. So this now gives us 10 marks. It says the marks obtained by 10 students scored out of 60 are shown. Now, the first thing I would want to do with this is put them in ascending order, especially because I ask for the median and the interquartile rate. So without hesitation, you want to put them in ascending order. Are they in ascending order? No. All right, so the first thing you want to do is put them in ascending order. We can do it up here, or we can just maybe do it right here. So we can divide it out and get the quartiles. We're going to break it up into the quartiles and so on. Right? So the lowest value, let's put them in ascending order. The lowest value is 26. Let's put it in blue. So the lowest value is 26. Let's mark it. The next one is 29. The next one is 31. The next one is 35. Then there's a 37 right here. All right, like I do have a speed. Let me put it at the top. Put it up here. Then we have 38 3 times. See there? 38, 38, and 38. 38, 38, 38. Then we have a 42, 42, and then we have a 45. 45. All right, let me shift that up some more. I'll shift it over some more so we can show how we divide it up, all right? Right here. All right, so those are my values. I put them in ascending order. And there are 10 values. So let's just divide it up from now. Let's just divide it up from now. Since there are 10 values, you have to add the median to the data. Because remember, you must have an odd number of values when you have a median. So divided 5 and 5. 1, 2, 3, 4, 5. Divided 5 and 5 first. And 5 and 5 up here. Then you have to add the median inside here, which is the average of these two. Average of 37 and 38 is 37.5 clearly. So this is my Q2 value would be 37.5. 37.5. Then Q1 now is the median of the bottom half, which is the value in the middle. And since there are 5 values there, one of them becomes the median of the bottom half, which is Q1, which is this value. So I know right away that this value is Q1. And then now again, there are 5 values up here. So the middle of the top half is the one in the middle. That value is Q3. So that's why you divide up the data and find the quartiles when the data is raw. Simple. Now, ready to calculate now. When the data is raw and ungrouped like that, well, raw data like that and want the range is just the largest value minus the smallest value. 45 minus 26. How much is that? 45 minus 26 is how much? 45 minus 26. 45 minus 21 is 25.
19.
25 minus 6 is 19.
24.
All right,
19.
19. Good. Next one, what's the median? See it here, bam. No, I would, if I, maybe, you know, maybe you would have to do this in this section to get the median, you know. All right, but I say, you know, to not miss, for example, if you're looking for the largest value, you might just pick out the wrong one and the wrong one for the smallest value. So the safe thing to do is to write them out in ascending order like that, so it becomes clear. All right, even though they don't appear to give you the space to do it, but maybe you could do it inside here, so do it right there, so in that little space, this little gap right in here. You could write them out in ascending order. You need to write them out in ascending order somewhere. You don't want to be doing it up here, because remember, you don't want to be working outside of these marks. You understand me? But that's because I'm doing it now, I put it there. All right, so on the median, we see that it is 37.5. Let's write it as Q2. May the examiner know, so we know the symbol Q2 is the average of the 37 and the 38 in the middle there. And clearly, half between 37 and 38 is 37.5. And notice, if they are given and it's marks, you know, scores, marks, it's actually marks, right? These are actually marks. So if you want to put the word marks on it as the unit of measurement for this data, you can put it as well as marks. Right? Is marks. This is the test scores in marks. The marks that they got. That's what the question said. These are marks. The next one, what is the interquartile range? I'm going to tell them now it is Q3 minus Q1. Based on our breakup, the Q3 is 38 and the Q1 is 31. See them here? 38 and 31. That gives us 7 marks. The interquartile range is 7 marks. Good. Next question says, that to determine the probability that a student chosen at random scores less than half the total score of the test. Remember, the total score of the test was what, 60, right? So basically, you want less than half. Let's see it again. The probability that a student chosen at random scores less than half. Less than half would be 30. That's what you're trying to find. Probability of less than half of 30 marks. Probability of less than 30 marks equals, you want to know how many persons score less than 30 marks out of the 10. How many scores were less than 30? See here, that's them 2 here alone. 2 out of the 10, less than 30. 2, so it's 2 out of 10. Score less than 30 marks. 2 out of 10, which is 1 out of 5. And you're done. That's it. 1 out of 5. But good at that?
Yes,
Yes,
sir.
sir.
Good. So you see, they try to play on words here. So with this question, less than half the total marks. They could have easily say less than 30 marks, you know, but they're playing on the words to make you have to think and so on. That's why they give 2 marks. 1 mark for say is 31 and the other mark for getting it right. All right, so that is all they do sometimes. Let's continue. Down here, it says this is a group frequency now. So remember, everything you do down this one is estimate. Estimate. Once the data is group, is estimate. Because I said they give it a midpoint. They give you the midpoint column. So the midpoint represents the group. It represents a group. And what this is saying is that there are 8 scores inside this group. You're assuming that all of them are 62, which is not true. You're using that to estimate. It says the frequency distribution below shows the mass in kilograms of 50 adults prior to the start of a fitness program. So like you have 50 persons who want to start a fitness program, and they measure the mass of the 50 persons. Because it's 50 persons, so many, couldn't list them individually down here. It's too many to list. So they put them in groups. They put the mass of the persons in groups. And so 8 persons way between this and this. But you don't know the actual weight of the 8 persons in that group. So what you do? You assume that all 8 of them weigh this midpoint value of this group. Assume that all of them weigh the midpoint. So you're saying 8 persons weigh 62 on average, right? That's the best way to estimate the mean. It says, on the grid, using a scale of 2 centimeters to represent 5, and on the x-axis 1 centimeter to represent, draw a frequency polygon to represent the information. So to do the frequency polygon, guys, you're basically plotting the midpoint against the score. So remember, you put the frequency on the vertical axis and the scores on the horizontal axis. And what you use for the scores when the data is grouped, you use the midpoint values. Right? So like you're plotting these values against these values. So like you're plotting a point 62.8 for that one. You're plotting some points. All right? So that is what you're doing. So you must put on this graph. But they tell you the scale. They tell you the scale to you. Let's look at the scale. They say on the x-axis is 2 centimeters to 5. Let's scale it up. 2 centimeters to 5. 2 centimeters to 5. Let's scale it up from down here. So this is going to be 5, 10, 15, 20, 25, 30. Let me see if I want to hold it or I have to break it. Maybe we have to break it. We have to break the graph, guys, because it starts at 60. So we can't start at 5. You can't start at 5. I break the scale and start at a value less than 5. We can't start at 5. Remember, values up to 60 don't really make sense, It makes no sense if you put no value up to 60. And that is the point. So since it starts at 60 here, you can actually start x-axis at 60, basically, because the first value is at 62. So we can come back here, so no, but we're gonna need to close it, right? We're gonna have to need to close it. So let's see what we have to close it. Let's put on what we need to close it. So to close it, we're gonna need 5 before this. So before this, because we close the polygon, we're gonna need 5 before this one, which will be 50, 57. That's gonna have a frequency of 0. And to close this end down here, we're gonna have to go to 92. Add 5 to this. 92. And that's gonna have a frequency of 0 as well. That is in order to close it. You have to close your polygon. So you close by doing 1 value before the first value and 1 value after the last value. So you have to start at least 55 in order to close it. You have to start at least 55 because you have to put in a point for 57. So let's start at 55 then. Let's start at 55. So you see, that's why you have to be smart. So we're going to start here at 55. So it's every 2 cents. So here is 60. Then here is 65. Let's do it in red. Let's do it in blue, sorry. So I put here at 55, start at 55. Then make this be 60, 65, 70, 75, 80, 85, 90. Also, we have to go up to last value was what? 92. Good. So you see it perfect. Then this is 95. All right. You could have also be smart and actually put these values as your marks to, these actual values, because they're going up by 5. They could have used those actual values as well, because they are going up by 5. So you could actually start at 57 and go up by 5. In fact, let's do that. So we don't have to estimate. Let's do that. Let's be smart and do that, because these are going up by 5 anyway. All right, so we could actually start at, let's start at the 57 and go by 5. So we don't have to worry about the in-between marks. So we're going to start here at 57 and still go by 5. It's okay to do that. So 57, 62, 67, 72, 77, 82, 87, 92, and 97. So you can do it that way as well. The interval is still 5, but you're making it easy for yourself because it means that all your points will be on these lines. You don't have to be searching in between here for points. Then on the y-axis, they say 1 to 1, right? On the y-axis, they say 1 centimeter. See there? It says on the y-axis, 1 centimeter to 1 unit on the y-axis. So it's just 1 to 1. And the y-axis went up to a maximum of 15. All right, 1 to 1. So basically it's 2 to 2 as well. So this will be 2, 4, 6, 8, 10, 12. So 1 to 1 is same as 2 to 2. That is it. So that's a scale. And then we're plotting the points. So we have to go back and forth, right? We have to go back and forth because we have to go back and forth. Let me plot the points in red. I plot it in, yeah, plot it in red and I close it in blue. So the first point is already closed, 57.0 and 92.0. Let's put in those 2 points first, 57.0 and 92.0. 57.0 is here, 92.0 is here. So we're gonna end up closing it when we're done. Put in the 2 closing points from now. Then 62 at a frequency of 8, so it's 8 and an 11. Let's put them in 2, 2. 8 and an 11. Let's put them in 2, 2. 8 and an 11. So 8 on the 62 will be here. And then the next one on the 67 will be 11 here. The next two would be 15 and then 9. 15 and then 9. The next 2 points. Oh, this needs to go up some more. Go up to 15. So this will be 14, sorry. And then this will be 16. So we saw a while ago, 15 and 9, right? So the next mark will be at 15 on this line. That's the next interval up to 15 right here. And then you drop down to 9 on this line right here. 9 will be here. All right, corresponding to the, I put the wrong place, eh? Oh, the wrong place, you know. See how the wrong place, guys? Wow. So this should be over here. This should be here. This should be here. This one should be here. And this one should be here. Let's just make sure. Right. So this one is down on the 62. This one is on the 67. This one is on the 72. This one is on the 77. All right. So we reach the 9. We reach the 9. And the last two is 5 and 2. 5 and 2 for the next two. So this one is down to 5. It's a 5 here. So this is a 5 line. So talking about here. And then 2 is on this line. 2. And we already closed them, right? So originally, if you plot the original points, you'd have just had these. You'd have just had straight line between here and here, straight line between here and here. That's where you draw the frequency polygon. You start out like a line graph. But good, but do you still?
Yes, sir.
All right. Just want to make sure. So you start out like a line graph. And draw a straight line here between those two. And a straight line between these two. Then a straight line here. And a straight line here. That's what you would have originally, but I had to put in these 2 points because the polygon has to be closed. So you close it, look at what the interval is, and you put a point before the first point and bring that frequency to 0 if you don't have one. And if you don't have a point at the last point down to 0, you put a point after, and that frequency is also 0, because those are not originally given. That's why they have a frequency each of 0. All right, and so you come and close your polygon now by a straight line down to here, and a straight line down to there. And basically, that's how you get a polygon, you know, with the x-axis, you know. That's what they call it, a frequency polygon. That's your frequency polygon right there. So like a straight line graph, but you have to close the two ends to make it into a polygon. And that's it. But okay with that?
Yes, sir.
All right, beautiful. All right. If they wanted a histogram on this just for practice, they wanted a histogram on this, then what would happen is that these will be in the middle of your bars and to go like so. The points will be in the middle of your bars, and your bars will be like this. If you wanted a histogram, that would be the first point. The second point would have extended up to here. That's if they wanted a histogram. So the midpoints will be in the middle of your bars. Look at it carefully. Right? And then join them side by side, and the bars are the same width. Just that those points are now being, those points will be in the middle of your bars. Like this. So I'm tracing out a histogram for you from what we have already. That would be a histogram that I've just drawn out in purple. If the question also wanted a histogram. Now we tend to do the frequency polygon after we draw the histogram, but it can go the other way as well. You can draw the histogram after the frequency polygon, but the key thing is that the points on the frequency polygon are in the middle of the bars, and the bars are the same width. So that would have to be a histogram if we wanted a histogram, the purple. So the red will be a frequency polygon. The red is your frequency polygon. Frequency polygon. So the purple would be a histogram. Purple, if they wanted a histogram, would be a histogram. If they wanted a histogram. So let's put in that for practice and revision, right? Show the connection between histogram and the polygon. That is it. All right, let's continue. Next question. Now this is, I say, your makeup time question in the exam, guys. Right? We just did this topic, a one-day topic on this. And we focused on the types where you're increasing by the same number each time. The pattern of numbers is one where you're increasing by the same amount each time. And we'll set up a quick way to do the formula, right? I'm using a formula approach. So this question says, a sequence of figures is shown. So let's go. A sequence of figures is made from toothpicks of unit length, meaning 1, like 1 centimeter. Unit means 1. Right? It says the first 3 figures in the sequence are shown. What does that mean? Like you have a triangle and you put a second triangle and you join the top of them, and then you put a third triangle, so you have 3 triangles now, and you join the top of them, right? So you keep joining the top. All right, so that's a shape. You draw the fourth figure. So the fourth figure basically is to put another triangle like this and join the top. That's what you have to do, you know, to get the fourth figure. Put another triangle and just join the top of this one. That's all. So what I can do to draw my fourth figure is actually trace out this one here. Let's trace out this one and copy it down and move it down. As I have a tablet, I'm doing it on the tablet. I can just do that. Right? Make it easier for myself right here. I like to do things the easy way. So I like to do mathematics the easy way. And just copy this down. And just move it. That's my figure number 4. But can I give it that? But I go do that?
Yes, sir.
Yes, sir.
All right, good. I like to do mathematics the easy way. Next part now says, study the pattern of numbers in each row on the table. Each row relates to one figure in the sequence, and in this case, I give it a figure number, so this is like an n, right? I give it the n. In fact, they put an n down here, like it when they put the n down here, right? And it says some rows have not been included. It says complete the rows, mark 1, 2, 3, and 4. In other words, complete the figures here for row 1, the figures here for row 2, the figures here for row 3, and the figures here. Now, as we did in the class, we like to fill out this one first because it helps you sometimes to fill out the others. So I like to fill out the formula row first. So to fill out this formula row, look at how the values are changing. This one is a steady pattern. You go from 3 to 7, you add 4. Go from 7 to 3, from 7 to 11, you add 4 again. So clearly this is a plus 4 situation. I keep adding 4. So since you keep adding 4, the formula starts with 4 times n. But because the first figure only has 3, in the first figure, the n will be equal to 1, you know. 4 times 1 is 4. To make it 3, you have to subtract 1. That becomes a formula, 4n minus 1. Then we can test it now in the second shape, where n equals 2. If I drop 2 on this, I'm going to get the 4 2 is 8. 8 minus 1 is 7, so it works. Let's test on the third one. Drop the 3 for the n here. 4 3 is 12. 12 minus 1 gives me 11. So I am now confident that this formula is correct. Then now, over here, the pattern, we're looking for the figure number in the pattern to use in the pattern. All right, what are the values that are changing? Well, these plus 2 stay the same. So we know that that's a plus 2, but these values changing. Eh? What do we observe? Let's look at it. This is 1 less than that. This is 1 less than that. This is 1 less than that. So the first number, the first digit in this expression is 1 less than the figure number. That is n minus 1. So it starts out with an n minus 1. Let's put it that way. N minus 1. 1 less than the figure number. That's how it starts out. Then you're adding the figure number. What else is changing? This value in the middle is changing as you go from row to row. But it matches the figure number. So it means that you're adding the figure number. So inside here, these are n values inside here. These are n values. So I'm adding n. So this is a plus n. And then now I'm consistently adding 2. See that? Adding 2. So that's constant. Keep adding 2. So this is a plus 2. That's it. And then now this can be simplified to become 2n plus 1. You can look at it now, it's 2n plus 1. Because n plus n is 2n. And then the minus 1 plus 2 is plus 1. So this can reduce to that. 2n plus 1. So all of this becomes 2n plus 1. I'm going to leave this on my paper and examine. That is this 2n plus 1. So I can write it like this and say equals 2n plus 1. It simplifies to 2n plus 1. So I could have instead written 2n plus 1 in there. But if to match the formula, this is what you have to write to match the formula in that row, not 2n plus 1. But because I have equal some number here, so this is what it is, 2n plus 1. All right? Well, let's fill out the rest of the table now. So I fill out my formula line first, then I'm going to fill out the rest of it. So for figure 4, I'm going to drop the 4 on this, and it will be 4 times 4 minus 1. That's 15. Which basically, because it is the next figure after the third one, you add 4 to this. All right? Which makes it 15 anyway, so you're confident that this is correct. Then over here now, we have 1 less than this to begin, which is 3, plus the figure number, which is 4, plus always adding 2. And if you notice, these look like they're going up by 2, you know. These are going up by 2. So a formula for this, see, they're going up by 2. That's why it becomes this formula, 2n 2n minus 1 and 2n plus 1 and look. It became 2n plus 1 as well. Look here. These values going up by 2. So it would start out as 2n. But the first value is at 3, so you need to add 1. So that's why I get back the 2n plus 1 under here. Anyway, right? It works itself out as well. But you're following the pattern that they give us. So this works out to be 9. Can you add 2 to this? So this becomes 9. That's a 9. All right? Then in this row now, they gave us this, which is quite easy. Because remember, the value in the middle here is always a figure number. So I know that over here is a 20. Over here is a 20 by observation. This is a 20. Then now I'm going to drop this 20 on the formula here to see what value goes there, which is 4 times 20 minus 1, that is 79, because that is 80 minus 1 is 79, goes here. Good. And then now to figure out the figure number for here, I'm going to put my formula equals 127. Put them equal to find out what the n is. So for this row, I'm going to put my formula equals 127 and solve it. That is 4n minus 1 equals 127. Add 1 over here, I get 4n equals 128. If I divide by 4, I'm going to get n equals 32. What I give it that? So this is 32. What I got it that?
Yes, sir.
Good. I know that that is 32. I can drop my 32 now over here because I must have 1 less than 32 first, which is 31. Plus the same 32 over here, so plus 2. And then I work that out. Now this is 34 and 31 makes 65. That's correct? All right, same as 64. But drop it on this formula right here. It becomes 64 plus 1. 65. So it is correct. And that is it. This is a makeup time question. So we can finish it. That's a makeup time question in the exam room. Don't take a lot of time to finish it. All right? Same thing must happen in the exam, especially when it's as simple as this. We keep adding the same number of values each time. Right? So makeup time. So you can literally finish this question in like 5 minutes in the exam room. So this is a makeup time question. We're running out of time. But all right, so far, moving on to section 2 now. But good?
Yes, sir.
All right, section 2. Ready, let's go. This question says, show by calculation that the roots of this equation are these. Now, once I see this, once I see this, it tells me that we basically solve this using the quadratic formula. Simple as that. All right, so I'm going to go and use a quadratic formula. What's a quadratic formula? That x equals minus b plus or minus the square root of b squared minus 4ac, everything, all over the 2a. I'm using that formula to solve this. What does that mean in this one? The a is equal to 1, a is equal to 1, the b is equal to 2, right here, the b is equal to 2, and the c is equal to negative 5. Negative 5 is the c. So I'm plugging these values in that formula to get the roots. All right, so let's go. So using that now, the x becomes equal to minus b, so that's negative 2, minus 2, plus or minus the square root of 4 of b squared, that's 2 squared, 2 squared, minus 4 times a, the a is 1, times c, the c is a negative 5, negative 5, all over 2 times a, which is 2 times 1 is 2. 2 times 1. All right? Let's simplify my space here, not a lot. So it becomes equal to minus 2 plus or minus. Let's work this out now. Inside here. Let's work it out inside here. So inside here, this becomes a 4. This minus, well, this becomes negative 20. So it's minus negative 20 becomes 24. So it's plus 24. Plus 20, sorry. So inside that bracket becomes 24. So it becomes the square root of that, which is square root of 24. Inside here, it becomes the square root of 24. So I'm going to write it, square root of 24 divided by 2. Now, how did they get that 6? Because the factorize is 24 and write it as 4 times 6. So it becomes minus 2 plus or minus the square root of 4 times 6. 24 is 4 times 6 all over 2. And then I break up the square root of 4 times 6 now and write as minus 2 plus or minus the square root of 4 times the square root of 6. Because that's the square root of this product becomes the square root of 4 times the square root of 6 all over 2. And then now the square root of the 4 is 2. So it becomes minus 2 plus or minus the square root of the 4 is 2. So you get 2 root 6, 2 times the square root of 6 all over 2. And then you divide this part by the 2, you get negative 1. And divide this part by the 2, the 2's cancel, and you get just the square root of 6 alone. And there it is shown. So the key step in this part, guys, is to recognize that this 24 breaks up into 4 times 6 if you want to show the work. But some calculators you enter this, and it write this for you, Some calculators, If you put that in the calculator, it write that for you, But I guess this is a question where you maybe want to see this work, this breakup, to see how you get the 6 inside here. All right, so that is it. Better go to that.
Yes, sir.
All right, beautiful. Let's continue to part B. It says, hence or otherwise solve this pair of simultaneous equations. Right? So clearly, when we go to solve this pair of simultaneous equations, we are basically going to be ending up somewhere with this because it said hence. So let's see. First thing we want to do with this pair of simultaneous equations is decide if we're going to use an elimination method or a substitution method. Normally use a substitution method for this kind of equation, pair of simultaneous equation, because this one is a line, that one is a curve. And the safe thing normally to do is substitute. You don't have to, but you can. So I'm going to substitute this one for the y. I'm going to take it and substitute for the y right here. So let me rewrite them. Just to have the space, the leverage to do it. So it's 2 plus x is equal to the y. And we have xy equals 5. And at the point of intersection, the line is saying y equals this. And the y value is the same. So I'm going to take that and replace the y here on the curve. Because the y on the line is equal to this. So it means that I can take this expression that the y is equal to and substitute for the y on the curve. That's how you substitute. All right? The y value is the same at the point of intersection. When we do that substitution, right? So we'll sub the line into the curve as I did there in red. We're going to end up getting that the x times where the y is, I'm going to put 2 plus x now, is equal to this 5. That's a construct. We'll make the substitution. I'm going to expand this out and transpose. We're going to get the x times this x is x squared. Then the x times this 2 is 2x. And then this 5 comes over and becomes negative 5. That's all equal to 0. That's the original equation that we got over here. See there? X squared plus 2x minus 5 equals 0. Well, we already know that when we solve this, we end up getting, we already know that this leads to x equal minus 1 plus square root of 6. Or x equals minus 1 minus square root of 6. That's what the plus or minus here stand for in this solution. One root is with the plus, one root is with the minus. So those will be the two x values that we're getting from this pair of simultaneous equation. This will be one of them, that will be the other one. Let's put the R on it. So those are our two x values that we're getting. Just like we're writing them in this format now. All right, we're writing them and leaving them like that. We call this a surge form. So those are the two x values, one with the plus and one with the minus. We want to find the y value to go with this and the y value to go with that. We're going to substitute them in the line equation. So we're going to sub into the line equation. What I'm going to do, I'm going to put the y on the left side. So I'm going to write it as y equals 2 plus x now. 2 plus x. So we sub this one in it first. So let's say at x equal minus 1 plus root 6. At this first point, y becomes 2 plus that, which is minus 1 plus root 6. This works out to 2 minus 1 is 1. 1 plus root 6. Right? So that's 1 point. And then at x equals the other one, this one, minus 1 minus root 6. The y becomes, again, 2 and then this, that is 2 minus 1 minus root 6, which this gives us 1 again, but then we have minus root 6. That's the solution, you know. When x equals this, y equals that. When x equals this, y equals that. We could put them as points now. Now let us spare. Let's put them as points down here. So the first point will be this as the x value and this as the y value. So you can write it as minus 1 plus root 6 is the x value, and 1 plus root 6 is the y value for 1 point. And the other point will be this x value and this y value, which will be minus 1 minus root 6, comma, this y value now is 1 minus root 6. I mean, they chose in this question to leave it like this, but no problem. So those will be your points if you're expressing them like in this format as coordinates, which you can. That is it. So I guess if you left it like this x value, this is the y value, and this is the y value corresponding to this x value, maybe they'll give it a mark still, but you could also express it, the answer as points, coordinates like that. But okay, with that, all right?
Yes, sir.
All right. Let's continue. This now is some grafting right here. It says the incomplete table below shows x and y values for the function y equals 2 to the x. All right? For integers from -1 to 4. All right? So they want us to complete here, here, and here, and here. All right? Those 4 values they want us to complete. That's what they're saying here. Complete the table for 2 to the x. So this first value here, so let's zoom it up. It's going to be 2 to the -1. 2 to the -1 is the same as 1 over 2. It's a half. So this is 0.5. Then this is 2 to the 0, which is 1. This is 2 to the 1. This one is 2 to the power 1, which is 2. This is 2 squared. Right now, you put in the x value and the power, right? That's what this means. Pen giving a problem, guys. Bear with me. So you put in this as your x value. So you're gonna get 2 squared. That's how you get in these values. So it should be now 2 squared, which is now 4. This one is 2 cubed now. 2 cubed, which is 8. This is 2 to the 0, which is 1. This now gonna be 2 to the 4th power, which is 16. 2 to the 4th power is 16. So those are the values. Right, let me underline the values for you in red. So 0.5, 1, 2, 4, 8, 16. All right. Then now they want us to draw a graph. It says on the grid provided on page 27, draw the graph of y equals 2 to the x using a scale of 2 centimeters represent 1 unit on the x-axis and 1 to 1 on the y-axis. So it's 2 to 1 on the x-axis. Let's go. 2 to 1 on the x-axis. So the x-axis here, 2 to 1. Let's scale it up. So 2 to 1. So this will be 1, 2, 3, 4, 5. Because it's 2 to 1. And where did it start? It started at -1. So we're going to need -1 as well. So this is -1. And this is 0. And then on the y-axis, 1 to 1, right? That's what it said. 1 to 1. See? 1 centimeter to 1 unit on the y-axis. So it's 1 to 1. So it's 2 to 2. 1 to 1 is same as 2 to 2. So on the y-axis, this will be 2, 4, 6, 2 to 2. This will be 1 and this will be 3. I was putting in the 2 intervals. Right? So this will be 8. It went up to 16, right? This will be 10. This will be 12, 14, 16. All right, and there were no negative values. All right, so the first point was half, -1 half, -1 half, and 0, 1. -1 half and 0, 1. Let's put them on in blue. -1, -1 was a half. Remember, this is 1, let's zoom it up. Remember, this is 1, So half is right here. This is 1, so right here is half. So -1 half is this point. Then you had 0, 1 is this point. 0, 1 is this point. Then we had 1, 2. Remember, 2 to the 1 is 2 right here. 1, 2 right here. Then we had 2 squared next, which is 4. 2 to the x became 2 squared, which is 4, which is right here. Then we had 2 cubed. 2 cubed for this one was 8. 2 cubed is 8. So we had this point right here. And then we had 2 to the 4th power, which is 16. So next point goes all the way up to 16 up here. 16 here. 2 to the 4th power, 16. Those are the points. And you're drawing a smooth curve through them. An exponential graph. So you draw the smooth curve through those points. Something like that. And that's your graph. What about that?
Yes, sir.
All right. So graph of y equals 2 to the x. All right. What else I want us to do? I must want us to read something from it down here. All right. It says, drawing appropriate lines on your graph, determine the value of x for which 2 to the x equals 11. So this corresponds to where y equals 11, Remember, it is y equals 2 to the x, So you're trying to find where y equals 11. What is the x value when y equals 11? That's what it is, So you're going to find 11 on the y-axis, go across on the graph and see what the x value is for that point. When the y value is 11, so you come up on the graph for 11, let's do it in different colors. Let's use purple. So we can estimate it. So it's 11. It's 11 here, so 11 is right here. This is where y equals 11, which corresponds to this point on the graph right here. That's the point where y equals 11. And I read down to see what the x value is there, so let's say it is right here. And we'll get the answer, we can test it now. Can test it and see if it makes sense. Test it with the calculator. That will be 3.6. This is 3.5, 3.6 right here. We're getting an x value of 3.6. But let's see if how accurate that answer is with the calculator. Because we are basically now saying yes on that 2 to the 3.6 supposed to be 11. That's what it means, you know. The next is 3.6, we're saying 11. So let's test it with the calculator. Let's test it with the calculator. Let's test it with the calculator. I like to test answers with the calculator, see if it is acceptable. So it's 2 to the power. Where's my 2? I'm going to put 2 to the power 3.6. I gone too much. Gone too much. I don't like that. Let's try a different value. Let's try 3.5. 3.5 look a better, I know. Let's try 3.4. Yeah, 3.55. 3.54. I have my calculator. I'm going to use it, you know. 3.51. Looks like 3.5 is the best answer. So I'm going to adjust it and make it 3.5, you know. I don't care. 3.5 is a closer answer, better answer. It all depends on how you draw this part of the graph. If you notice, on mine it is kind of coming out a little bit. Maybe it's supposed to be a little bit straighter, like that. You get me? So it all depends on how you draw the graph. So maybe 3.49. Let me say 49. Even better. 3.9, 3.4. Yeah, 3.45. Let's give them 3.45. Let's give them 3.4. I'm in the exam, I have my calculator, I'm going to use it. I'm going to use it. So let's give them 3.45. You have to help yourself and get a more accurate answer. Right? So it all depends on how you draw this part. I remember you're drawing it with the freehand now. So some people might draw it a little bit straight, so some people might draw it a little bit round away there. It all depends on how you draw it, right? So I'm making my adjustment. I want an accurate answer. So I'm going to make it be 3.45. So I'm putting it there instead. I want an accurate answer. You can do that. Help yourself. I'm going to put it right down the middle here. So get a good answer. I'm going to say 3.45 and give them that as my answer. All right? That's more accurate than the 3 point thing. I have a calculator, I'm going to test it. 10.9, it's closer to 11. So I'm going to give him 3.45 as my answer. All right? I will be smart. Keep my answer close. So I'm going to say 3.45. X equals 3.45 over here. X equals 3.45. That's what I'm getting. Give him that. Examiner wouldn't see what you're doing to your calculator to get an answer that is accurate, you know. I'm making sure, you know. It all depends on how you draw this part of the graph with your free hand, right? So that's what it is. Everybody answer is going to be a little bit different. Some people might put 3.5, 3.6, 3.55, whatever. But I guess anything within the range that kind of close enough, they'll give it a marks. Or anything you get from your graph, they give it a marks. But that is it. But go to that. Any questions?
Yes.
But okay. All right. I think that finishes that question. Yep. Done. 2 more questions to go. Let's go. Next one. Circle theory. Circle theory. This question says diagram below not drawn to scale shows a circle center O. So this is a center O. Remember, this is an isosceles triangle. It's a sector triangle. It's isosceles because this is a radius and that's a radius. And since they give me one angle in this isosceles triangle, I am blessed. I can easily find these two. But total angle triangle is 180 and them two, they equal. The two are equal. I'm just giving it that as a start. I can see that this is a cyclic quadrilateral. This is a cyclic quadrilateral. This cyclic, got the 4 vertices are on the circumference. What else do we know? This right here is the angle between a tangent and a chord, right here. Tangent and a chord. So it means that the chord subtends the same angle at the circumference up here. So I know right away that this angle is also equal to the 80 note there. So angle between a tangent and a chord equals the angle subtended by the chord. And so those are some of the features that jumps out at me. All right. Next thing, angle at center is twice angle at circumference. This angle at the center is subtended by this chord. Same chord is subtending this angle up here at the circumference. Try to have a different color for you. Same blue chord is subtending this angle at the circumference. So this angle is half of the 114. Because angle at center is twice angle at circumference subtended by the same chord. So looking at it, those are some of the things that pick out. Next thing, these are two tangents. Two tangents rule. Two tangents from a single external point. This tangent and this tangent. Two tangents from a single external point. These are two radii connecting them. The two tangent and the two radii forms a cyclic quadrilateral. Why? Because this angle and this angle are both 90. So these two angles must add up to 180. These two angles add up to 180 degrees. So it means that the one down here is 180 degrees minus the 114 degrees. And the two tangent and the two radii is a cyclic quadrilateral. All right, so those are just some of the features that jumps out at me right now. But let's answer the questions. All right, so it gives us the two tangents, right? Tangents, right? And the angle here is 114 at the center, and the angle over here between the tangent and the chord over there is 18. All right, let's see what that asks us to do. Calculate given reason for each step in the answer. The measure of angle ACD. Where is that? ACD. All right. So they want this angle up here so now. Oh, sorry. They want this angle up here so now. ACD. How do I get that angle? Let's look at the thought process to find this angle. If you don't see how you can get it, let's look at it. I said it to you already. I just said it to you now. They want to find this angle up here. What do? Find the chord that is subtending it. So you come back to limit the circle. It means a circle at this point and this point. Those two lines forming the angle. So this is a chord that is subtending that angle. That same chord is subtending this angle at the center. The angle at the center is twice the one at the circumference. So it means that this one out here must be half of the 114. Because the angle at the center is a larger one. It is twice the one at the circumference. So I'm going to write it here, sir. This angle is half of the 114 degrees. What is that equal to? 57? That's correct? 57 degrees. Are you there still, students? I don't want this thing cut. Oh, I don't want this thing cut off and I don't know, you know. I'm going to tell them the reason. Angle at center is twice angle at circle. I'm saying giving reason, you know, guys. I have to say it. Angle at center, the center rule, is twice angle at circumference. That's the reason. That's the center rule. Angle at center is twice angle at circumference. That's why that angle there is 57 degrees. So I'm going to put it on there now. So this angle up here is 57 degrees. Let's put it on in red. All right, I'll mark the diagram as I need to for you to see we get them. So this angle right inside is 57 degrees. All right, let's continue. The next angle that I want is angle AED. Let's see where that is. Angle AED. AED. This angle that I want, no. Easy. It is supplementary with that one. Because the two tangent and the two radii is a cyclic quadrilateral. So that one is 180 minus the 114. So this becomes equal to 180 degrees minus the 114 degrees. What that work out to? What is that? Somebody, what is that?
66.
I'm not working out everything, 66 degrees. What's the reason? I'm simply gonna say the two tangents and the two radii is a cyclic quadrilateral, opposite angles are supplementary. Let's try that. Two tangents. I just say it's a cyclic quadrilateral. Let's say what the shape is. The shape is OAED. Let's say it. Can't say it's a lie, I tell it. OAED is a cyclic quadrilateral. The opposite angles are supplementary. And that's why you do the 180 minus. Supplementary means that they add to 180 degrees. That's why we did that. We know that two tangents and two radii. Two tangents from a single external point and the two radii connecting them forms a cyclic quadrilateral, this thing. Because the opposite angles are supplementary. So these two angles supplementary. So this is 114, then the one down here must be 180 minus 114. So we get 66 degrees. Let's put on the diagram, 66 degrees. So right down inside here, this is 66 degrees. Doing the mathematics the easy way. All right, that's that. There are other ways to get it, but I'm doing it the easy way. What else I want? Angle OAC. We don't use the thing there yet, we don't use the tangent and chord rule yet. OAC and then ABC. OAC first. OAC. Let's see where that is. OAC. 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 No, that is this little angle inside here, so. That the one, no, that little angle there. All right. So to find that little angle inside there, what we're gonna have to do, we're gonna have to recognize, firstly, that this part of it, we're gonna have to do a difference thing. We're gonna have to find the whole of this angle first, and then find this angle which is 18. One was 18 because it's subtended by this chord. Right? That angle inside here, so it's 18, subtended by that chord, which is making an angle of 18 degrees with this tangent. And then now, this other angle here now is inside the triangle. That's a this triangle, and then it's gonna be the difference. It's gonna be the difference. So basically, it's like we need to calculate this angle first. Those two are the same. All right, so let me mark it on the paper. Let me mark it. Let me mark this angle here in blue. That's what it is. So this blue angle is 180 degrees minus the 114 degrees divided by 2. That's what it is, because it is equal to this one. All right, so that is basically the calculation. Let me shift this over. And I'm going to leave these markings on the paper, because I just want to keep it simple. What I work out to? That's 66 divided by 2, don't it? Which is 33 degrees, right? 33 degrees. But I give it that. But I give that, that is 33. Good. All right, that is 33. And then now, we want this angle now. So I'm gonna mark a different color for you. This angle here in purple now. That angle is 18 degrees. Right? Why is it 18 degrees? But the angle between a tangent and a chord is equal to the 18 over here, equal to the angle subtended by the chord. So I'm going to write it right here. Easy way. Angle between tangent and chord equals angle subtended by the chord. Now, trust me, you can do it just like this on exam paper to you now, guys. And the examiner see it and see how you get your angles. You know. And therefore, the angle that you want is 33 minus the 18, the difference. That's the angle AOAC up here, so now. It's the difference between them. Right? So when I say that, so I'm leaving this on the paper. And then I have my reason here. For this one, I can tell them it's an isosceles triangle for this one. I can put the reason here as well. And so for this one, is because that triangle is isosceles. So I can say total angle in isosceles triangle, and the isosceles triangle is ADO, right? Or OAD. Isosceles triangle OAD. Isosceles triangle OAD is 180 degrees. That's why we divide by the 2 because isosceles. All right, so that gives us that. So when I take the difference now, so it becomes 33 minus 18. So the angle that I want down here becomes 33 degrees minus 18 degrees. What I work out to? 33 minus 18 is how much? Somebody work that out for me. I don't have to work out everything.
15, sir.
How much?
15 degrees.
15 degrees. All right, then the last angle I want now is angle ABC. Angle ABC, that's where that is. Angle ABC up here. ABC. All right, so we can get that angle now. All right, so you know, so this angle up here is a different color. Let's use red. This angle up here is supplementary with this angle across here. So we can find this angle here, can do 180 minus, right? But another way to do that one, to get that angle, is to recognize that that angle is subtended by this chord. Use a different color, use a different color, so you can see. Let's see if there's a green. Let's see if there's a green that we can use. All right. Right. So this angle that we want up here is subtended by this chord. That chord is making this whole angle with this tangent. So the tangent here, and between the tangent and the chord is this angle. So it means that this chord is making that same angle at the circumference up here. So if I were to mark them, if I were to mark the two angles I'm talking about, yeah, it's the same green. Then this angle up here that we want is equal to the angle down here. So how do we get this angle down here now? We can add it up. Let me erase these and see. I'm trying to find this angle right here.
Let it go for long.
How do I get this angle? Because I have the purple piece, which I know is 18, right? No, that was 18. Yeah, that little angle right there is 18. And then we can find this angle now. Because this is also an isosceles triangle, you know. Right? That's an isosceles triangle. In fact, this angle here is going to be 57. I want to know this angle is 57. I'm sure you know it's 57 because it is the angle between this chord and the tangent, and the chord is obtaining 57 up there. But you could also know that this is 57 by working in this triangle, right? And say that this is an isosceles triangle, or this tangent and this tangent is the same length. So these two angles that I'm marking now, this one and this one, equal. What are they equal to? 180 degrees minus the 66 divided by 2. That's going to be 57 degrees as well. Multiple ways to do it. And so, because that is 57, you're going to add the 57 degrees to this 18 degrees inside here, so. And you get the whole of the angle here, so. And the whole of that angle is the angle between the tangent and the chord, which means it's the angle subtended by the chord up here, right up here, so. So this angle also then is 57 degrees plus 18 degrees. What I told for me, guys?
Did you not tighten the base on?
Huh? What is that equal to? What is that equal to? 75? Somebody will thought and tell me.
75.
So why am I have to work out everything myself? 75.
75.
That is it. Understand how I got it? I just want to see if you understand how I got it.
Yes, sir.
All right. So I use a tangent and chord. That's not the only way to do it, you know, because as I said, we could also work to find this angle down. Let's do it another way and see if it's actually 75. Let's do it another way. Let's do it another way. I could do it another way by finding this angle down here. Now that angle can be found easily, you know, because remember that inside here, so this is 18. Right here says 18. Right? And right here says 57. And I'm focusing on this triangle now. Total angle in that triangle is 180. So this is a 57 and it's a 18. Then this angle that I've marked right here. Where's the green that I was using a while ago? And this angle here that I've marked is 180 degrees minus the 18 and the 57. All right? 180 minus the 18 and the 57. And then now, these two angles supplementary. So if you work this out, what are you gonna get? That's 180 minus 75, that is 105, right? It's 105. And then if you use the supplementary angles now, then another way to get this angle up here using cyclic quadrilateral rule is 180 minus 105. 180 degrees minus 105 degrees, which is going to give it a 75 anyway. So you could have gotten that the other way as well by finding this angle here first, working in this triangle. That's another way we could have done it. All right, I'm not going to bother to go back to write on the rules. You'd have to write out all of that, right? In the interest of time, that is it. But I understand, I just want to make sure everybody understand.
Yes, sir.
All right. Hold on then. All right, that is it. So I gave you 2 ways to find the angle, right? All right, so that finishes that question. Let's move on, unless I'm going to copy these down. But it's all right. Let's in the interest of time, let's move on. All right, let's get back to this one now. This question says the diagram below shows a cuboid. It says, when it says, you can see the dimensions on it, right? It's a cuboid. The side is 20. And we can see those dimensions. It says a straight adjustable wire. I think I told you about this question one day. You know? A straight adjustable wire connects R, see R here, to P. That's on the top of this diagonal. I say it's a rectangular cuboid, so right is at 90 degrees. You know? So this triangle is a right angle triangle. Right? This length is also equal to this length. So this length is also 100. Let's say calculate the length of the wire. So like you're working in this right angle triangle right here on the top. And this is the hypotenuse that you want. So you're going to use Pythagoras' theorem. So length of the wire, RP, is going to be the square root of 100 squared plus 60 squared. But you can say that using Pythagoras' theorem. But I give it that.
Yes,
Let
sir.
me get the calculator. All right. 100 squared plus 60 squared. Because that's Pythagoras' theorem. In that right angle triangle. I told you about this question in class, and I remember it when I was talking about these 3D shapes. So the square root of 100 squared plus 60 squared. That becomes 116 and 116.6. I'm going to give it the three significant figures. I'm going to call it 117. 117 centimeters. That is 117. It says the connection at P is adjusted and moved to T. Calculate the length of the wire RT. So let's look at it now. Let's look at it. So what happens now is that this connection that is here, with a different color, is now moved. This is moved down, such that this wire now is moved to this. Now if I now focus on this triangle now, by joining this length and coming back on this length that we already know, then that also is a right angle triangle. Where this now is the right angle. I'll just work out this length up here as 117. So this length is 117. Now this becomes the hypotenuse at the wall now in the triangle. 117 and 20 is 20 in that triangle. This is one side, this is 117. This is now a new hypotenuse. Right? So we're working now hypotenuse bounded by 117 and 20. Right? So that new length RT, let's work it out in red. RT now is now the square root of the 117 squared plus the 20 squared. So we're going to do the square root of 117 squared plus 20 squared. That becomes 1, 1. I'm going to call it 119. The three significant figures, I'm going to call it 119. 119 centimeters. I'm going to work with 119. That piece there. Cross it in the middle of the box. But it goes so far? But okay so far?
Yes, sir.
All right. The next part now says we have to calculate angle TRV. Angle TRV. Let's see where that angle is. TRV. So the now one angle TRV. Now TRV is this angle. Let's mark it in a different color. Let's mark it in green. Let's mark it in the green. It's this angle. See? T up to this, down to V. That's here. So I want this angle. But that's kind of easy because that angle, TRV, if you use Z angles, is also equal to this angle that I'm marking now in green. Those two green angles equal enough. Right? Because of the Z, see, it's a Z angle you have. See the Z there, Z angles. So those two angles equal, they are Z angles. So to find this angle, we can come and work in the triangle and find this angle instead. Alright? Find this angle instead. To find that angle, what we can use this as the opposite and this as the adjacent. Right? If I show the working out right here, for that angle, let's just call that angle alpha. So we're gonna call this angle alpha. This angle over here that I want is also alpha. So based on that, working in this triangle, this is the opposite and this is the adjacent. So we can say tan of alpha equals the opposite of 117 over the adjacent of 20. And so alpha is tan to the minus 1 of the 117 over the 20. And you work it out. So you're doing tan to the minus 1 of a fraction 117 over 20. And that is 80.3 degrees. 80.3 degrees. I can copy this down as our calculation. Down here for the angle. Let's change the color. That's it. Everybody good at that? So I want to make sure everybody's okay with that.
Yes, sir.
I want you all to redo these questions, and no joke. Redo the questions. All right. Next one says, complete the following statement. The size of the angle through which the wire moved from RP to RT is what? Let's look at it now. Let's look at the diagram. This question is normal. I like it a lot. It's not normal. So the angle through which it moved from RP to RT. Let's look at the diagram. So they're talking about this angle, you know, as it moved down, you know. Let me use a different color to show you again. Let's get let's do it in. Yeah, let's use the blue. I want to use the blue. So it's when it moved from this line RT down to this line. So that angle they're talking about is the angle where you drop it down here. So that angle they want. Right? Now, if you're working in this triangle, I'm sure I'm gonna mark out this triangle in this yellow now or this orange. If you're working in this triangle now that we're marking out in orange. This triangle. It's a right angle triangle. Right? And we know this angle inside here is 80.3. Now that angle, these two angles over here, so must add up to 90. So the angle that they're asking us for inside here. Inside here is a different color now. Go back for the blue. Angle that they're asking us for inside here must be 90 degrees minus the 80.3 degrees. Right, this here is already 19, right? Here is already 90. So it means that these two angles, this one and this one, must add up to 90. That's why I'm doing 90 minus that. Right? So I'm going to subtract the 90 minus that. We're going to get 7.9, so 9.7 degrees. So 9.7 degrees. 90 minus 80.3. So see here, it is 90 minus 7.3 is 9.7 degrees. Angle through which it move. 9.7 degrees. And said an angle which is the same as angle RTV. Let's look at it now. An angle which is the same as RTV. So looking for a Z angle now. Which angle are they talking about? RTV. Now RTV, this question is easy though. Now, let me erase some of these things, right? Because they're kind of making it confusing. Let me erase some of this. Let me draw about this line. And draw about this line up here. Diagonal up here. So they're asking us now about this angle, RTV. So I'm gonna put on this line on the diagonal on the base now, you know. That diagonal on the base. So asking me for this angle, RTV. This angle they're asking us about right inside here. So that angle, you know, is equal to this angle up here now. That we just found, you know, the 9.7, you know. Because of the Z, let me mark out the Z for you with a different color. Let's mark out the Z with this orange. See if you can see it. So we're talking about the Z angle now. Along this line, the VT, up this diagonal, and then across this other line across here. That's the Z. So then this angle down here that asking us about in here is equal to the angle up here that we just found. And that angle is PRT. Right? So angle RTV is equal to angle PRT. Angle RTV, not P, RTV, angle RTV is equal to angle PRT. This is the relationship. This is it. This is it. Okay. Place it down and so. So it's angle PRT that one. PRT. RTV is PRT. Z angles. All right, that is it, guys. I want you to go and do over this question, right? Last question now. What time is it? It's now 1:40. That's what it is now. We're doing a full, almost a full paper now, so it's gonna be lengthy. The classes are gonna be lengthy, so get used to it. All right, get used to it. So that's what it is. We're doing full exam papers now. All right. Vector, let's finish off with this one. It says vector OP and PQ and RS. So give us these three vectors. That, and that. And they're asking us for OQ. So you can look at what we have now. We have O to P and we have P to Q. So from O to Q, we can just add these two. Let's look at it. O to Q, going from O to Q is the same as going from O to P that we have and then go from P to Q. Not complicated. So just add these two and we get it. So you add the 3, 4 and the -1, 2. And you get the OQ just like that. Going from O to Q is the same as going from O to P with this one. And then go from P to Q with this one. And you end up with OQ. So 3 and -1 is 2. 4 and 2 is 6. Easy. That's it. What good at that? What okay?
Yes, sir.
Show that OQ and RS parallel. Then parallel one is a multiple of the next. The OQ, we have it as 2, 6. Just find it here, so. And the RS, we have it as 1, 3. Obviously, that one are bigger than this. The 2, 6 is 2 times the RS. 2 times this one. So we can literally just say that. The OQ is clearly 2 times the RS. The big one is 2 times the small one. Therefore, them parallel. Therefore, OQ is parallel to. This is like a symbol for parallel. These two little lines like that. is parallel to RS because 1 is a multiple of the next. We are able to express 1 as a multiple of the next. It means that they are parallel. The OQ is clearly 2 times the RS. Those numbers easy. Done. Next part. It says XYZ is a triangle. M is the midpoint of XZ. XY is A, YZ is B. Now look here, them I tell me about a triangle and them don't show me none. I want a visual. I want to be able to see it. So because I want to see it, I'm going to draw any triangle and just label it up. It don't matter. I'm going to draw a triangle and name it X, Y, Z and put information on it. M is the midpoint of XZ. It's XZ here, so I'm going to put M right here, so M, as I said. Then I'm say XY is the vector A. Let's put it on. I'm going to put A on this vector, make it become visual so I can see it and reference it. Put on A on this. I'm not working blind. YZ is B, so YZ is down this way. YZ is B. Right? And up here says A. So it's more clear to me now what can go around this diagram, right? So I go up here, so, and then go down here, so. So if I want to go from X to Z, I can go up here, so, and then go down there, so. That's A plus B. And that's what I'm asking for first, XZ. Yes, on this diagram, X to Z, I just go from X to Y, and then go from Y to Z, which becomes A plus B. That is XZ. Then I'm on MY, go from M to Y. Easy. To go from M to Y, I can do it one of two ways. Let me use a purple and show you. To go from M to Y. Right? I can go M to Z and then go from Z to Y. If I go Z to Y, I'm going in the opposite direction to that. I think that's the easy way to do it, you know. Why is that? Why is that? Because I already have XZ across here. And the MZ is just half of the XZ. Let's do it that way. So I'm going to go from M to Y by going M to Z and then Z to Y. Let's write it out. I'm going to go M to Z and then Z to Y. Z to Y. The M to Z is half of the XZ. So this is just half of the XZ. And then the ZY is just basically minus B, because I go in the opposite direction. So this is just minus B, because ZY going in the opposite direction. And then half of the XZ is just half of these values now. So I'm going to get half of A plus half of B minus a whole B. So this reduces to half of A, and then half minus 1 is negative a half. Half of B minus a whole B, given minus a half B. And that is it. And I can check if this makes sense to go from M to Y. So this is saying go half of B and then go minus, no, go half of A and then go minus half B. Let's see if it makes sense. To go from M to Y. Half of A first. See here, look at the diagram now. This is a whole A, a whole A. So if this would be a whole A if I was to go there. But I'm only going half. So half is going to take me there. That's half A now. And I want minus half B, which makes sense. Let me reach the midpoint on this side. So you got minus half B now. This way. Minus half B. So it makes sense. The answers make sense. I can accept those answers. I can accept those answers based on this diagram. That done. What else is there? Then we have some matrices down here, so now to finish off. All right. It says A is this matrix, B is that matrix. Must calculate the inverse of A, inverse of this one. So remember, it's 1 over the determinant, A minus 1. Let's write the formula. A to the minus 1 is 1 over the determinant of A times the adjoint of A. 1 over the determinant times the adjoint. Let's work it out, yes or no. So A to the minus 1 equals 1 over the determinant. What's the determinant? This product minus this product. What is this product? This product is negative 2. Minus 1 times 2 is negative 2. Minus this product now. Second diagonal product is 0. Multiply that more by the adjoint. We get the adjoint. Interchange these two elements on the first diagonal, they interchange them. So write them as 2, negative 1. Then these two other ones on the second diagonal, leave them where they are and change the sign. 0 on the sign, so it just come back as 0, but this 3 comes back as negative 3. So this basically becomes A to the minus 1 equals 1 over negative 2 times 2, 0, minus 3, minus 1. If I write to a single matrix, I'm dividing each of these values by this negative 2. So 2 divided by negative 2 gives me, hold on, I think I messed up something. All right, so ready, equals 2 divided by negative 2 is negative 1. 0 divided by negative 2 is 0. Negative 3 divided by negative 2 gives 1.5. Negative 1 divided by negative 2 give me another positive 0.5. That's my matrix, A to the minus 1, right there. It says, show that A to the minus 1 times A equals the identity matrix. Now for this, you have to know that the identity matrix is 1, 0, 0, 1. I'm going to multiply the A to the minus 1 and the A, using this as the A to the minus 1. Right? So that is, the A to the minus 1 is minus 1, 0, 1.5, 0.5. And I'm using this time with the decimals, because 1.5 and 0.5 are easy decimals to work with. Otherwise, I would have used this one as my A to the minus 1. Multiply that by the A matrix, and this is the A matrix right here. Minus 1, 0, 3, 2. I will multiply these, I'm supposed to get this matrix, right? So you just have to show the calculation. It's going to work out, but you have to kind of show some calculation. Remember, I multiply the rows of the first matrix by the columns of the second matrix, right? So the first value here is the first row times the first column. So it is a negative 1 times 1 and a 0 times 3. Negative 1 times 1 is 1 and 0 times 3 is 0. Then this value over here now is this row and this column. Everything is 0 because it is negative 1 times 0 and 0 times 2. That is 0. Remember now, the first element times first element, second element times second element in the row and the column. So this is 0. Then the value down here now is this row times this column. So that one now is negative, is 1.5 times negative 1 and 0.5 times 3. All right, so that becomes, this times this is negative 1.5. And then 0.5 times 3 is 1.5. So add in 1.5 to this. That's why I get a 0. Let me shift this over some. This value to so is 0. And then the last value down here now is this row times this column. First element times first element, second element times second element. So it's 1.5 times 0 is 0, and half of 1 is 1, plus 1, plus 1. And then when you simplify these values, you get the matrix. This becomes a 1, this stays a 0, this becomes a 0, this stays a 1, which is the I matrix. So you have shown it, so therefore shown. The identity matrix for multiplication. That's it. Anything else? Yes, because we're not doing this yet, you know. Person along, we're not use this yet, you know. We're not use the B yet, you know, unless we don't need to use it. Person I wait sometimes, you know. Okay, we have some use for it down there. Then what? A squared. Remember, A squared is really just A times A now. A squared is A times A. So there's no shortcut. You cannot square the value. You have to actually multiply them out, right? A times A. All right, so remember A is minus 1, 0, 3, 2. So you're going to multiply minus 1, 0, 3, 2 times minus 1, 0, 3, 2. A question that kind of longish to me, relatively long. They don't usually ask to multiply 2 by 2 matrices twice, you know. They don't usually, but that's what it is. So we're going to work this out again. Give it to you to do, you just have to do it. So we're doing the rows of the first matrix and the columns of the second matrix. All right, so the first value here, 4 values are going to get. This first value is the first row times the first column. So it's first element times first element, second element times second element. First element times first element, second element times second element. Minus 1 times minus 1, and 0 times 3. So the minus 1 times minus 1 is a positive 1, and the 0 times 3 is 0. And this element over here is first row, second column. So using this first row with this second column. First element times first element, second element times second element. But negative 1 times 0 is 0, and 0 times 2 is 0. So this value is just 0. This just works out to 0. Then the value down here now, here is second row, first column. So to get it, using this second row with this first column. First element times first element, second element times second element. Let's work it out now. So it is 3 times minus 1, which is negative 3, and 2 times 3 is 6. So add in 6. And this final value now is the second row, second column. So using this second row with this second column. So it's 3 times 0 and 2 times 2. 3 times 0 and 2 times 2. The 3 times 0 is 0, and the 2 times 2 is 4. So this simplifies out into, this becomes a 1, this stays a 0, this becomes a 3, this becomes a 4. That's the answer. Let's write this better. It's a 4. That's it. Then down here now, it says, explain why the matrix product AB is not possible. This is a conformable thing, right? So let's say what we can do. The A is a 2 by 2. That's the A. And the B is a what? The B is a 3 rows by 2 columns, a 3 by 2. 3 by 2. So the B is a 3 by 2. Now these two numbers not equal. This number of columns not equal this number of rows. They are not equal. That is why the multiplication is not possible, but you have to say it, right? Because it explain. That's because the number of columns in the first matrix is not equal to the number of rows in the second matrix. That's the reason why it's not conformable. And put this equal thing over here. So these two values are not equal. So you're going to say number of rows in the first matrix is A. So you can just say in A is not equal, not rows, number of columns, not rows, number of columns, number of columns, number of columns. That's why it's COL for column. Number of columns in first matrix, which is 2, is not equal to the number of rows in the second matrix, which is B. That's why it is not conformable. All right? So it's not conformable because the number of columns in this first matrix is not equal to the number of rows in the second matrix. For them to be conformable for multiplication, the number of columns in the first matrix must be equal to the number of rows in the second matrix. They don't have that. And it says, without calculating, state the matrix, say the order of the matrix BA. So BA would be a 3 by 2, but that would be a B matrix, a 3 by 2, times a A matrix, which is a 2 by 2. Now, this will be possible because you have these number of columns here, and number of rows here equal. And the answer, the resulting matrix, will take the number of rows, let me put it here, in a different color. It will take the number of rows on the first matrix, which is 3, by the number of columns in the second matrix, which is 2. So this would be the answer, the final matrix, the answer. It would be a 3 by 2 matrix. And that is that. Always stay, body good? Body okay?
Yes, sir.
Yes, sir.
We have to get comfortable and familiar with these lengthy classes, you know, guys. Can't be afraid of these lengthy classes, you know. I see a lot of people running down to do 11-hour marathons and all these things, you know. Right? Remember, the exam is 2 or 40 minutes. You have to get comfortable with doing a paper for 3-4 hours. Right? You get comfortable with that length of time. That when you go in the exam, that is 2 or 40 minutes, you are comfortable. You can focus and concentrate for the full 2 or 40 minutes in the exam room on the exam day. You get me? So we have to get comfortable with classes that are lengthy and learn how to focus. We cannot learn how to focus for that length of time unless we practice it. Do it, practice it and do it time and time again. So because we're doing the majority of the questions on the papers now, our session's gonna be lengthy, but in fact, we don't have much more of this to do online because from the 16th of March, you will be coming to the mock exam face-to-face in the exam room here. All right, you'll be coming to school to do the mock exams face-to-face from the 16th of March. So maybe next week is the last Saturday. We're actually gonna be online like this. All right, on the 16th, you're coming to the classroom to do the mock exams. So you're going to be doing full exam paper for the full 2.5 hours, practicing the time management, learning how to manage the time properly, the right way. We're not taking anything for granted, everything important. Even how you manage the time in the exam room is very, very important, critically important. It's something that you have to practice. You cannot wait on the exam day and just go and do something. With all the plans that you have, what you're going to do on the exam day in the exam room, you have to practice it before. So when you get to the exam room, it becomes second nature to you what you do in the exam room. You have to get comfortable with the structure of the exam paper. You have to get comfortable with sitting down for that length of time and working a paper and being focused for that full length of time with no distractions. No phones, no nothing to distract you, no talking, no noise, nothing. Just doing the exam paper for the full length of the time and learn what that length of time feels like. So in the exam room, you kind of have a feeling if you're running out of time, if you're falling behind. But still, as I said, we're going to have a specific time management plan that we're going to be using in the exam, and we have to practice it over and over again, multiple times, right? Everything important. Every single thing about doing this exam is important. Even how we manage the time. I have to practice it. I'm going to practice it multiple times, starting from the 16th of March. All right? We're going to be practicing. Some person won't be able to come on the Saturdays. We have to make some arrangement for them to do those mock exams just the same. The more mock exams we do, the better. We're going to be doing 2 mock exams per week, at least 2 mock exams per week. There's going to come a time we're going to be doing like 3 mock exams per week. Every class is going to be a mock exam eventually. All right, so that is it. All right, guys, so that's it for the day. All right, we're into March now, so it's serious time now. Once we get to March, guys, like a different Mr. Shaw you're gonna see, a different Mr. Shaw, a different story you're gonna see now. Intensity, turn up now. And I want all of you to be just like that. You have to turn up the ante now. No more time to lay, no more time to joke around. All right? Serious time, serious business now. We're working towards exam now, and we're only working for distinctions, guys. I mean, nothing less than a distinction is good enough right now. It's a subject that you should get a distinction in. One with straight A's. We have to prepare for it, work towards it. All right. So just be prepared now for some high level of work, high intensity of work from March right through to the exam. All right. And then we can relax when the exam is over. So no more relaxing, guys. Serious time now. All right. All right. That's it for today. Those who have class tomorrow. See you tomorrow. We're gonna do another 1 day topic tomorrow and a 1 day topic on Wednesday and Thursday next week. And we'll get back to the plane and solid geometry, which is not a 1 day topic. All right. We're gonna finish up a couple 1 day topics and then we'll get back to the regular schedule. We should just have a couple more projector-like topics to do, teaching topics to do. All right, guys. So see you all tomorrow and Monday. And as I said, when I send the video, I'm going to send it right after. This is one of the YouTube ones. I'm going to send the video right away. I want you to redo the questions, especially if there's a question that was given a problem, you're not so sure about it. You need to redo the questions. Use the video to help you. This is time for you to follow those instructions and do those things. No joke. No joking around now. Serious time, serious business. All right? So, bye, guys. See you all in class. All right? Bye, everybody.
Bye, sir.
Okay, then. Cool.